Hello ladies and gentlemen, test review time. You get the crash course, pretty much the same thing. Let's do another study guide. If you can do all these things, there is nothing I will put on the test that you are not going to crush. So, let's start off with, this is section A1 if you're following along with the book sections. You have my math lab here. Exponents and radicals. First thing, parentheses mean multiply. There's no powers outside here, so I don't have to worry about that. I'm just going to add. When you multiply with the same base, you add. So 2/3 plus 1/3 is 3/3. 3 divided by 3 is 1. So this is x to the first. Y to the 3/4, y to the 5/4. When you multiply, you add. 3/4 plus 5/4 is 8/4. 8 divided by 4 is 2. That's y squared. So x, y squared, that's your answer. For the second one, you have a power to a power. The rule is you multiply a to the 6th, b to the 9th. The denominator, that's a cube root. So you can use the rule here for 6 times 1/3 and get b squared. Or you can think, well, there's two groups of 3, so they both make it out. But you need to remember that the 8 is also under that cube root. The cube root of 8 is 2, so it's 2b squared. Now, if there's 9 b's in the top and 2 in the bottom, you can cross 2 of them out. And that will then be b to the 7th in the top, and the 2 is the only thing that's left in the denominator. So a to the 6th, b to the 7th over 2. For the radicals, I will make a factor tree. So you can do that however you want. If you can do it in your head, great. If you can't, make a factor tree. Doesn't matter how you do it. You got to get a factor tree. 3, 9, 27, 81. That's a power of 3. X to the 6th, y to the 5th. So for a cube root, we're looking for sets of 3. Got one. That means 1 3 makes it out. That's because 3 times 3 times 3 is 27, and the cube root of 27 is 3, so it's now outside of the root. There are 6 x's, so we got to think, well, if there's 6 of them, then there will be 2 groups of 3, so 2 groups of 3 will be x squared on the outside. If there's 5 y's, you'll have 1 group of 3, but there's still 2 left on the inside. So let's figure out what's on the inside still. We have a 3. We brought all the x's out, but there were still 2 y's because they're the leftovers. So 3x squared y times the cube root of 3y squared. Same idea here. 64 is a power of 2. So we'll do 2, 4, 8, 16, 32, 64, x cubed y to the 6th. We're looking for groups of 4 because it's a 4th root. Got one. So that 2 makes it out. There's not enough x's. There are enough y's. There's one set of 4 for the y's. What's left on the inside? 4th root of 2 times 2 is 4. There weren't enough x's. We brought 4 of the y's out, but there's still 2 of them left in there because there's 6. So 4x cubed y squared is left on the inside. Nonlinear inequalities. So you want to solve these like any other equation here. 6x squared. If it was a quadratic, you would set it equal to 0, and then we'll factor. Well, it's greater than or equal to 0. Okay, we're still going to factor. 6 times negative 5. The numbers we need, multiply to negative 30 and add to the middle. The middle is 13. Be careful, it's not 10 and 3. That would be if they have the same sign. They're going to multiply to negative 30. So 6x squared, this is going to be plus 15x minus 2x. And we want to know where it's greater than or equal to 0. So the GCF for the first two terms is 3x, 2x plus 5. Bring down the minus sign. The GCF between those two is 1, 2x plus 5. And then you have 3x minus 1 and 2x plus 5 as your factors. You want to know where this is greater than or equal to 0? Okay, cool. So to find where it's greater than or equal to 0, we first want to figure out where it equals 0. The zeros are at 1/3 and negative 5/2. The way I'm doing that is write a little mini equation. When does 3x minus 1 equal 0? Add 1, divide by 3. When does 2x plus 5 equal 0? Subtract 5, divide by 2. So you can do them in your head. They're two-step equations, but if you want to write them out, you can do that too. Let's put those on the number line, negative 5/2 and 1/3. First thing, when you plug these in, you get 0. So if I plug in 1/3, this factor will be 0. 0 times everything is 0. Is 0 greater than or equal to 0? Yes, it is. So we're going to put a closed circle at these points because they do work. Now we're going to test points that are in each interval. So we're going to pick a number that's to the left of negative 2.5. Let's do like negative 10. Now we're going to plug it in right here. So we're plugging in negative 10. 3 times negative 10 is negative 30. Plus or minus 1, still negative. 2 times negative 10, negative 20. Plus 5, still negative. So since the first factor is negative and the second factor is negative, their product is positive. If you pick a number between these two, like 0, the first factor will be negative, the second factor will be positive. A negative times a positive is a negative. Pick a big number, like 10. 3 times 10 is positive, minus 1 is still positive. 2 times 10 is positive, plus 5 is still positive. Their product is positive. What interval do we want? Well, first, understand, this is a parabola. I'm not graphing the whole thing. I'm just kind of saying, like, look, this is what happens along the x-axis. It's above the x-axis to the left. It's above the x-axis to the right. It's negative, below the x-axis in the middle. We're just sketching the behavior on the x-axis. We're not necessarily drawing all the y values. I don't really care. I just want to know if they're positive or negative. What interval do we want? Greater than 0. Another word for greater than 0 is positive. So we want the positive intervals. So I will then shade the positive intervals, which are to the right. It didn't work. Fix it. To the right and to the left. So in interval notation, the way we say this, to describe this interval, we're going forever to the left. So that's negative infinity until we get to negative 5 halves. Now that one works. It's a closed circle, so we use a bracket. But you can never get to infinity, so we use parentheses for infinity always. Union, there's another interval. We start at 1/3. That's a bracket because it's a closed circle. And it goes forever to the right, so we say infinity, and again, that's always parentheses. So these are the intervals. This is saying all the numbers smaller than negative 2.5 and all the numbers bigger than 1/3 will work to solve your original inequality. Let's do the same thing here with a rational. So we're going to do something similar where we find the 0, which is when 3x equals 0, which is when x is 0. But we also want to know when the denominator is 0, because the denominator of a fraction can never be 0, which means in this problem, if you subtract 1, x can never be negative 1, because then you divide by 0 and you break the function. You can't divide by 0. So we've got our points of interest here, 0 and negative 1. I'll put those on the number line, negative 1, 0. And since you plug in, let's start with 0. When you plug in 0, you get 0 divided by 1, which is 0. And 0 is less than or equal to 0. So for 0, we're going to put a closed circle. But negative 1. If you plug in negative 1, you divide by 0, and that does not work, so that is an open circle. You've got to be very careful there. Now let's do the intervals. Pick a really negative number. The numerator will be negative. Pick a really negative number, add 1, it's still going to be negative. Their quotient will be positive. Pick a number in between negative 1 and 0. How about negative 0.5? 3 times negative 0.5 is negative. Negative 0.5 plus 1 is positive. Their quotient is negative. Pick a big number. The top and bottom will both be positive, which means the quotient will be positive. We want the intervals that are less than 0. Less than 0. Another way of saying that, we want the negative interval. We want the one that's negative, the one that's got a minus sign. So the way you say this in interval notation is from negative 1 to 0. 0 has a bracket, but again, you cannot plug in negative 1, so that's parentheses. So negative 1 to 0. Moving along, let's factor. So when you factor, first thing, recognize there are two terms. So in the parentheses, you need to have two things, and they're going to be separated by minus sign. Something on the outside is your GCF. It's important you know that. 3 and 6, GCF is 3. X plus 1, x plus 1. You always factor out the negative exponent. You don't think about it. X plus 1 to the negative 1 half. Okay, fine. That's always the case. X plus 2, x plus 2. Well, this guy only has 2 of them, so I'll factor out 2. That's my GCF. What's left? 3 times 1 is 3. X plus 1 to the negative 1 half, that's fine. X plus 2 squared, I need a third one. X plus 2. When you distribute, you will get this term now. Minus. 3 times 2 is 6. This is the weird part. We factored out a negative 1/2 amount of these. There's a positive 1/2 in the top. So when you're factoring, you're dividing that out. If you take 1/2 and you use the exponent rule, subtraction, 1/2 minus the negative 1/2 that you factored out, that's the same as 1/2 plus 1/2, which is 1. So when you divide that out, you're going to end up with x plus 1 to the first on the inside, which is weird, but that's how it works. We already factored out both the x plus 2's, so we're good there. All we need to do is simplify the inside. X plus 2 minus 2x minus 2, I'm just distributing. And x minus 2x is negative x. Oh, the 2's cancel out. That's cool, I guess. So the only thing left on the inside is negative x. And then our GCF is still x plus 1 to the negative 1/2 x plus 2 squared. So there you go. Let's try another one. So here we'll factor out in the top. So I'll find the GCF between those two. That's 2x. And then x minus 1. How many can I factor out? This guy's got 4. This guy's got 3. I'll factor out 4. What's left on the inside? Well, 2x times 2 gives you 4x. And this needs another x minus 1. Minus 2x times 1. Oh, that's the whole thing. So if the GCF is what you're factoring out, you just need to have something here to multiply by so that when you distribute, you get that term again. We're going to put a 1 there. That's like our placeholder. If I multiply these guys, I get the first term. And if I multiply this guy times 1, I get the whole thing there, that second term. Now this is all over x minus 1 to the 5th, which I'm going to do it right now. Look at that. If you have 3x minus 1's in the top and you have 5x minus 1's in the bottom, you can cancel out 3 of them and you will end up with 2x minus 1's in the bottom. X minus 1 in the bottom. We still have 2x in the top. Those all canceled. Then what is this? 2x minus 2 minus 1, so that would be 2x minus 3. And that is your completely factored form. So you can cancel out some of those binomial pairs. Cool. Let's keep, well, that should be squared. Because, we again, 3 and 5. So we canceled out 3 of them. There's 2 left in the bottom. Cool. Let's try rationals. So I'm not going to do all the split the middle steps. If you can't split the middle, you need to go back and learn how to factor. Like, that's a big deal. You are not going to do well if you cannot split the middle. Period. This is a sum of cubes after I do GCF. So 2x cubed plus 8. So if you remember, sum of cubes, the formula is a squared, ab, b squared. And then we use SOAP. So in this one, the same, the opposite, always positive. SOAP is our trick. So the cube root of x cubed is x. The cube root of 8 is 2. So I have x, I'm bringing down my 2. There's my 2. And then cube root, x2. X squared, ab is 2x. And b squared is 4. And then, like I said before, same, opposite, always positive. That's the top. In the denominator, I'm going to sort of guess and check my way through this factoring. You should probably work it out. I need numbers that multiply to 50 and 20. Multiply to negative 70 and add to 3. So to get numbers that multiply to negative 70 and add to 3, I think I want 10 and negative 7. So, plus 2 minus 7. 5x squared plus 10 minus 7 minus 14. There you go, that works. Does anything go away? Yeah, that goes away. So you have 2 x squared minus 2x plus 4 over 5x minus 7. Now, this kind of looks factorable, but when you do sum and difference of cubes, it's never going to be factorable. So you are finished. That is your answer. Let's try another one. Number 10. Again, I'm doing all the factoring in my head. If you can't do the factoring in your head, work it out. If you can't work it out, you are in trouble. X minus 2, x plus 1. This is dots, so the square root of x squared is x. The square root of 1 is 1. X plus 1, x minus 1. Here, that will be x plus 2, x minus 1. And then we also have dots. X plus 2, x minus 2. So a lot goes away, I think. X minus 2, x minus 1. So it's tempting, like these are on the same side of the fraction bar, so we're just going to write this as x plus 1 squared over, in the bottom we have x plus 2 squared. Okay, that's kind of cool. One more, copy, change, flip. This is a Division problem. So first, before I do anything, I'm going to copy the first part. That's not going to change. And then I'm going to flip this. So I'll take this guy. Now you're in the bottom. And this guy. Now you're in the top. So I copy, change, flip. Now it's a multiplication problem. So it's just one big fraction bar. These are all quantities that all need to be factored. So you need to factor all of them. Let's see if we can do that. So the first one, I'm going to factor, like I said, I'm going to do these in my head. So let's see. I need numbers that multiply to negative 36 and add to 5. So I think I'm going to use 3x and 4x because that makes 12. And then multiply to negative 36 and add to 5. I think I want 9 and 4. So let's do 3 and negative 1. 12x squared plus 9 minus 4. That's 5 minus 3. That works. 2x plus 3. Again, split the middle. You don't need to watch me do it. Split the middle. You should be able to get that. This is dots. 2x plus 3, 2x minus 3. And then I'll do the same thing down here. I'm going to factor this guy. So since 3 is prime, I know it's 3x and 1x. And then I need numbers that multiply to 3 and add to negative 4. So that'll be negative 3 and negative 1. So when I split the middle, it'll end up being both negatives. What goes away? That it? 4x plus 3 over. In the bottom, you have 2x minus 3 and 1x minus 1. Cool. That's rationals. What else you got? Modeling? All right, let's do it. So, it says we got 72 feet of tape, and we're taping off the crime scene something like this. So we'll call this the width. So we're going to tape that off this way, we're going to tape that off this way, we're going to tape that off that way. That's the width. And we'll call this, let's say that L, and there's 2 of those. So first thing, you got to find 2 equations. It doesn't matter if you can connect them right off the bat. Just find 2 equations. What would the perimeter of this be? There are 3 x's and there are 2 l's. X plus x plus x, L plus L. And if you have 72 feet of tape, that's a perimeter. The other thing we're talking about is area. So the area of this rectangle would just be L times X, length times width, L times X. But what we have to do is create a model that is A of X. We can't use A equals L times X. We have to say A of X. So we're not allowed to write L. We got to get rid of the L. The way you get rid of the L is you solve for L in the other equation that you have. So I will solve for L by subtracting 3x and then dividing everything by 2. So L equals 36 minus 3/2 x. What that does is it lets me do a substitution. Now instead of L, what I'm going to write is that. So 36 minus 3/2 x, that's L times x. And this is your model. If you want to simplify it a little bit, you can. I'll say 36x minus 3/2 x squared. If you want to distribute the x in, you can. Now you need to graph it. So this is where Desmos comes in. So you're going to need to graph it using Desmos, which I will do. Let's go Desmos. And we're going to say A of x equals negative 1.5x squared plus 36x. You can type it in either order. You are responsible for being able to do this, to rescale your graph so that you can understand what you're looking at. And what I'm going to do is I'm just going to take this picture, and since all I really need is that vertex, I'm going to screenshot it so I can talk about it. Here's my picture, my graph. This is my model. You need to know what your model tells you. What are we looking at here? So first thing, what is the x-axis? What is the input? The x-axis is the input of the function, which is x. So x is the width of the rectangle. It's this little distance here. We're calling the width, or x. What's the output? The output is the y. That's the area. So if it says, what is the maximum area that can be taped off? The maximum area is the biggest y value. That's 216. So that'd be 216 square feet can be taped off. How would you do that? Well, you would set the width equal to x, or I'm sorry, 12. X is 12 when that's your ideal area. So how do you get the length? Well, you can do it a couple ways. You can divide 216 divided by 12, or you can use this equation. So L equals 36 minus 3 halves of 12. So L equals 36 minus 12 divided by 2 is 6. 3 times 6 is 18. So L equals 18. So X is 12, L is 18. So what are the dimensions? 12 feet by 18 feet. This little distance is 12, 12, 12, 12, and the long distance is 18. If you add those up, 12 plus 12 plus 12 is 36. 18 plus 18 is also 36, and they add to 72 feet. So that's the entire problem. You need to create a model, you need to graph the model, and then you need to know what you're looking at. What else you got? Is that everything? I think we got some nonlinear inequalities here, don't we? Or is that all of it? Okay, well, that seems to be all of it. We already did nonlinear inequalities. So if you can do that, you can ace this test. So if you have any questions, get them answered before your test. Good luck, and be sure to hit that like and subscribe button.